Okay, this video is intermolecular forces. So, what are intermolecular forces? Intermolecular forces are the attraction between two different molecules. For example, the force of attraction between two water molecules is an intermolecular force. These forces are weaker than the normal bonds that hold together atoms. So they are weaker than ionic and covalent bonds, the bonds that actually hold together the molecules that are being attracted towards each other. And that's because the word inter just means in between. So intermolecular forces means the forces between two molecules. So there you go. So the first kind of intermolecular force is called London dispersion forces. A London dispersion force is an attraction resulting from the constant motion of electrons, and so you are kind of making an induced dipole. What that means is that you are in an atom, the electrons are moving around, and sometimes all the electrons are on this side, and then sometimes all the electrons move to the other side. And so when you have electrons that move in there, it is a momentary dipole, which means like a magnet, for a very brief moment, it makes two sides, a negative side and a positive side. And so those will attract and repel each other, and so that's called a London dispersion force. It is the only intermolecular force that affects nonpolar molecules. And it is present in all molecules because guess what? All molecules have electrons. And so if you have electrons, you can have an induced momentary dipole. Okay, the second one is just normal dipole interactions. And what that means is the attractive force between two polar molecules. If there is a polar covalent bond, let's say hydrochloric acid, then you will have a polar molecule, and then the positive side of hydrogen will attract the negative side of chlorine, and you have the attraction from a dipole, a polar molecule. Okay, obviously it's present in all polar molecules. The third type is called hydrogen bonds. This is going to be the most important and the one that you run into the most. And hydrogen bonds are the attraction between a hydrogen atom and an unshared electron pair. And it only occurs in these elements. So it is the attraction between a hydrogen atom and either fluorine, chlorine, nitrogen, or oxygen, but only those. F, Cl, N, and O. If you want to remember it from a name, you can say Fonkel. F-O-N-C-L. Kind of like Hofbrinkel, but now it's just Fonkel. Okay, so here's a diagram. These are water molecules, right? H2O, so two H's and one oxygen. And here's another water molecule. Here's another one, here's another one, here's another one. Hydrogen bonding is actually the attraction between hydrogen and the other oxygen. So you can see that a water molecule actually has two hydrogen bonds because it has two hydrogen that can actually quote unquote bond with this oxygen because this hydrogen is attracted to the unshared electrons that are on this oxygen. Okay, in water, the hydrogen bonding is responsible for a lot of properties such as surface tension. When you remember how water kind of bubbles up and how little bugs can float on top of the surface, that's because on the surface of the water you have all these small bonds forming and creating a very high surface tension. It's also responsible for the reason that water expands as you freeze it. Normally things get smaller when you freeze it, but water actually gets bigger. Don't believe me? Get a glass bottle of Coke, stick it in the freezer and see what happens. And so what happens is these hydrogen bonds actually will make water expand as you freeze, and you would break the glass. Okay, so here's the relative strengths of these bonds, because we need to know which ones are stronger than the others for, let's say, testing purposes or in life. We just need to know this. So obviously, in normal bonds between two atoms, ionic are the strongest. They're stronger than polar covalents, and then polar covalents are stronger than non-polar covalent. Okay, but then how about these intermolecular forces? So hydrogen are going to be the strongest, remember, most important. Next one is dipole interactions, and then at the very end is London dispersion. And remember, London dispersion is kind of very random. It goes on and off, in and out all the time, so they're very, very weak and they're very sporadic. Okay, so the last thing that we got to cover before Friday is properties of bonded compounds. So the first thing we need to talk about in this section is that ionic bonds form a crystal lattice. And so after all the transfer electrons have taken place, after all the electrons have moved, you know, chlorine has stolen all the electrons from sodium and they've all transferred, the ions attract each other, positive and negative, and they form an array which we call a crystal lattice. Okay, and so this is an example of a picture of a crystal lattice. Letter A is kind of the little molecular ball form, and then B is kind of a ball and stick model showing you the crystal part. Okay, so this is why most ionic compounds form a sort of crystal if you let them grow slowly. Okay, if you don't believe me, grab a microscope and get some salt. Remember, down here, this example is NaCl, which is table salt. Grab some table salt, look at it under a microscope, and you see this. Okay, so this is table salt under a microscope, and you can see that you have little tiny square block crystals. And that's because the crystal lattice forms a cube, and so you get a cube crystal. This over here on the left is actually a rock. It's actually called a mineral called halite, which is completely made of salt, NaCl, and you can see that halite forms cubic crystals. And that's because of the structure, the lattice structure. Okay, so in all this talk, we haven't discussed about just plain metals, okay? So how do two metals interact with each other? And so we have this thing called a metallic bond. And a metallic bond is a bond between two metal atoms. And what happens is that most metals easily lose their valence electrons. So most metals have either 1, 2, or 3 valence electrons, and they will very easily lose them. And so what happens is you get a big group of metals, which they call a community, and they share all the electrons together. And they call this a sea of mobile valence electrons. Okay, so you have a bunch of metal atoms, and the electrons belong to everyone, and they share them, they move around all the time, which is why it's like a sea of moving electrons. So here's an example. So this is the little atoms on the inside. These are the metal atoms, metal nuclei. And then on the outside, you have all the electrons. And you can't tell whose electrons belong to whom because they are sharing them all. So it's a little bit kind of like covalent. You are sharing electrons, but you are sharing electrons with everyone. And so we call that mobile because they move just like an automobile or an automobile. Okay? They move around, so we call them mobile electrons, and they act just like a big sea. Here's another example, except not as fun because it's not moving. You have silver, charged silver nuclei, and then the electrons that kind of float in and out. And the way that silver stays together is because this electron attracts the positive and the negative attract, which attracts this, and this attracts, and that attracts that, and that attracts, and so the sea of electron holds silver all together. Okay? So what we're going to find is the fact that we have this sea of mobile electrons will determine our properties of metals. And if you remember way back when we started talking about properties and chemical and physical properties, there's 4 properties of metal which you should know. The first one is luster, and that means whether it is shiny or not. The second one is hardness. You know, most metals, you don't want to get hit in the head with a piece of metal. Usually doesn't feel good. Number 3 is ductile and malleable, which means basically that you can bend them. Ductile means that you can make them into wires, and malleable means that you can hammer it into a shape or bend it. And lastly, 4, conductors of heat and electricity. Okay, and so of these 4 properties of metal, what we find is that all 4 properties are caused and direct results of the fact that they have mobile electrons that can move around. It's what makes them shiny. It's also what makes them really hard. They're bonded together really well. It's also what makes them bendable and ductile. And obviously, it's going to make them conduct electricity because you have a lot of electrons ready to move out of the way and make electricity. Okay, and so here is a summary of the properties of ionic, covalent, and metallic things. Really, you just kind of have to have this memorized. Go over it, copy this into your notes, use it for studying. I am going to, as the last thing, briefly explain all of these individual properties. Okay, so first property is electrons. Ionic, covalent, metallic. Okay, this is review. Ionic, transfer of electrons. Covalent, they share electrons. Metallic, mobile electrons. How about types of elements? Again, this is more review. Ionic is metals and nonmetals together. Covalent should just be nonmetals. And then finally, you have metallic bonds, and metallic is only metals. That's the stretch, I know. Metallic metals. Gonna be hard to remember. Okay. Finally, you have melting and boiling points. Okay, ionic, you think of salt. How high do you think you have to heat salt to melt it? Well, it's pretty high. Higher than you could survive. So melting points for ionics are very high, and they're usually solid at room temperature. For covalents, think of things like gasoline and oil. A lot of covalent bonds are actually liquid or gas at room temperature, so they have very low melting points. And the metallic, most metals are solid at room temperature, so they have very high melting points. How about solubility in water? Can you dissolve ionic compounds in water? Yes. Think of salt. You can dissolve salt in water. What about covalent? Well, it depends whether it's polar or nonpolar. If it's polar, yes, you may dissolve it in water. If it's nonpolar, no. Think polar. Water molecules are technically covalent. They are polar. Water molecules will dissolve in water. What about oil? Oil is nonpolar. Oil will not dissolve in water. Metallic, good luck trying to get metals to dissolve in water. You can't even melt them yet. Okay, how about conductivity? Okay, conductivity, ionic and covalent, pretty low. Salt doesn't really conduct electricity. Conductivity, technically polar molecules conduct, but actually, no. Conductivity for covalent is low, and the metallic, very high because of their mobile electrons. Okay? So, that is the properties, and that is intermolecular forces. So take those notes, and I will see you on Friday.